Okay, so I wanted to show off the device before I seal it up. So here we've got the project box, and I've drilled a couple holes in here. So this is the ultrasonic sensor that's been hot glued into place. And then on the top of it, we've got a hole for our cellular modem, and then for an LED. So I'm going to flip this over and show you what it looks like on the inside. So if we go down here, we can see there's the back of the ultrasonic sensor that's glued into place. Then we've got our USB cable here. We've got the modem with our Soracom SIM card in there. And then we've got this red LED over here that comes out there. So these are all wired up out to these GPIO pins here in the Raspberry Pi Zero. So here we've got our sensor and the LED plugged in, plus we've got our SD card that's running the latest version of Raspbian, and it has our Python scripts to make this all work inside. So then we've got the cellular modem into USB into this port here, and then for power we're running that into this power bank here. And then to turn this whole thing on, as long as this is charged up, we just need to hit this button. So we've got 1 bar left at the moment, but you can see the Raspberry Pi is coming on now, and we should see a blinky light. So the modem is trying to connect to cellular now. All right, so here we are in the GitHub repo for my water level detector project, and we're in the main Python script right now, so ultrasonic_beam. So this is the meat and potatoes of the entire project here. So we open up with our imports. We're importing a lot of just standard Python libraries, as well as 2 files that are also in this repo. This one gives us access to a read function, which lets us read the latest distance value from our ultrasonic sensor. So for example, if we point this device at a body of water, the distance between the sensor and the top of the water, this read function would let us get that distance. And then within LED, we've got an LED on and LED off function that we can use. So if we go down a little bit here, this is a helper function that lets us generate timestamps. And the format here is what the Azure Anomaly Detector API prefers. So in here, we're about to start our loop. And the first thing it'll do is it'll do a little bit of cleanup. So if this device was on previously and then turned off and then back on again, it'll just look for old data, old values that are stored in a CSV file, and if it finds them, it'll just remove them. That way, every time we turn on the device, it's starting fresh. So now we hop into our loop here, and here we are getting the latest value from that ultrasonic sensor and saving it into distance. And then we're prepping our headers and payload to then post this information up to Soracom Beam, which will in turn send it, will convert it to HTTPS and send it along to Azure. So we're going to grab our timestamp using our helper function from above, and then we're going to get our value from here, and we're going to round it, and we're going to use that as our value. So what we're going to do is we're going to take that sensor info and we're going to save it to a local CSV file, just because it's a quick and easy way to save kind of like a ad hoc database of all of the most recent values that we're getting. So we're going to append to this file. If it doesn't exist, this plus means that we're going to create it. And then we're going to start writing each value and timestamp as a row. So we're going to just make this long CSV file here and keep adding to it as we go. Then we're going to try opening it, and we're going to check and make sure that we've got at least 12 points in there, because this the anomaly detector API requires a minimum of 12 values. So if we've only captured less than this so far, it's just going to loop again, and it's going to keep adding to this counter until it hits 12, and then it's going to move forward and post this to Beam. So we have our granularity set to per minute. The anomaly detector API also supports hourly, I believe. And then sensitivity, this is a fun value to play with. So this is the threshold for how sensitive the API will be when detecting an anomaly. And then we've got our URL set up here for Beam, and notice that it's just HTTP. So we're not using HTTPS for this, since our cellular connection is already encrypted. This also means that we don't have to manage our subscription key or our endpoint for our API in our code either. We can do all that from the Soracom dashboard. So here we are, we're actually making the post here with our payload of all of our values. And then here we're going to grab that response, and then we're just going to print it to the screen, and we're going to get a key value pair back from Azure, and it's going to be isAnomaly, and then we'll get a Boolean true or false back. So with that, we can kind of act on that. So here in this part of the code, we're saying that if that value is true, we're going to turn the LED on. This is the area where if you had any other ideas for what your device should do when it detects an anomaly, this is the area in the code where you would paste that in there. So one idea would be that it could send an email, or it could send some other type of alert, or it could forward it along to some other system and do something even more interesting. So that would all go in here. And then if not, it's just going to turn the LED off just in case it was on from the last loop. And then it's going to go back to sleep, and then it'll loop again shortly. So that's the code.